Now in this video we will learn about Taylor series. We will learn how to write a recursive function for Taylor series. First of all, we will generate the idea how we can prepare a recursive function for this one. Let us observe Taylor series, then we will devise a method for writing a recursive function for Taylor series. So let me read it out. See, e power x, so for any given value of x, it is nothing but summation of these terms. As many terms as you take, we get more precise value. So here it is n term. So you can continue the summation up to some term, few terms, whatever you want. Here in the example, I have written up to power 4, that is total 5 terms, that is power 0 to power 4. Now, how to write a recursive function for this one? So if you observe, there are 3 operations performed in this one. One is summation of terms, and another one is power of x. X is raised to powers every time. Then in the denominator, there is a factorial of 1, factorial of 2 and 3 and 4, so on. So there are 3 values that are involved here. In our previous videos, we have already written recursive functions for sum of first and natural numbers, that is sum of first and natural numbers 1, 2, 3 goes on to n. And we have also written a function for finding factorial of n, that is number n, that was 1 into 2 into 3 into goes on to n. And we have written a function for finding power of x power n, that is m power n we have taken. So this is x into x into x into x goes on for n times. We have already seen this. We have already written recursive functions for this. We said that sum of n is sum of n minus 1 plus n. So we have written it like this, sum of n minus 1 plus n. And this factorial of n minus 1 then into n. So we have written it like this, factorial of n minus 1 into n. And this we wrote power up to n minus 1 times. So this was power up to n minus 1 and into x. So we have written these recursive definitions already. Now for Taylor series, actually we have to combine these 3 and write a recursive function for that one. So let us observe few things. Here if you see the first value n, so the recursive call will start from n and it will be go on reducing up to 1. And then it will start adding. So the addition of values is done at returning time. So actual addition starts from 1 onwards. So if I take the value of 4, sum of 4, then this will call sum of 3 and plus 4. This 4 will be added at returning time. Then sum of 2 plus this 3, sum of 1, then plus 2, sum of 0, then plus 1. The sum of 0 is 0. So while returning, this is 0, then this is 1, 1 is added, then this in this 1, 2 is added, and total is 3, and then here 3 is added and here 4 is added. So you can see that the addition is done at returning time. So similarly, for finding factorial also, product is done actually at returning time. So the starting point will be 1 and the last value will be multiplied will be n. And similarly in the power also. Now for Taylor series, what we want is, we want 3 things: summation and power, as well as we need factorial. So this x is raising to some powers and also we are getting factorial. Now a function for Taylor series must perform 3 operations, but the function can return only one result. Like this is sum of 3 numbers plus 4. Like this is sum of 2 numbers plus 3. So here sum of these terms plus this term we can do. But what about the power and factorial? So power and factorial cannot be returned by a function. Function can return only one value. So when you have to involve multiple values in a recursion, then you can use static variables. So let me show you how we can frame a recursive function for finding e power x using static variables. First, I will try to devise the method, then I will write down a function for that. Let me take the example for e power x for 4 terms, means total 5 terms it will be. So highest degree is 4. Now let us devise a recursive procedure. For that, I'll take the example up to power 4, that is highest power 4. So let me write the function as x and 4. Let us start with this one. So I am first doing the tracing, then I will write down the function based on that. Now what we want, so when it is x comma 4, it should call itself by 3. So okay, it will call itself by 3. Then it should call itself by 2. Okay, then 1, then 0. Now when it is 0, it should return 0. So okay, it will return 0. So the result of this is 0. Now what we need for this term, actually for this function, we are here. So what it should do, x by 1 it should do. So okay, I will write it as 1 plus x by 1. 1 plus x by 1. This is what I want, x by 1. Now this result is returned here. So the result of this function will be 1 plus x by 1. Now for this term, for this function, what I want is x square by 2 factorial, and this should be added. So I need this x and 1 so that x is multiplied with numerator, so it becomes x square, 2 is multiplied with denominator, so it becomes factorial. Then when I go back again here, so this result will be given to this function. So the result of this function is 1 and x square by 2 factorial. Now for this function call, it should be x cube by 3 factorial and plus 1. So in this function call, it should become x cube. So for making it as x cube, I need this x square. So in that I can multiply it by x and obtain x cube, and then I need 2 factorial, so that I multiply it by 3, so it becomes 3 factorial. Now for handling these two values, that is numerator and denominator, I take 2 static variables. First is x power, so this is power p I will take, and then next is denominator, that is factorial, so I'll take it as f. Now initially I will write them as 1 1. So assume that this is x power 0 and this is 0 factorial. So we have these initial values, that is for the first term. Assume this. Now let me trace this once again. So I'll remove these and I will utilize these static variables in this recursive calls. Now let us start again. For this function call x comma 4, that is I want total 5 terms, that is highest power is 4. So for this it will call itself with 3, then 2, then 1, then 0. So for 0 it should return 1. So that is this term, that is 1 it is returning. Now when it goes back here, what it should do, I need the term 1 plus x by 1 for this call, So let us multiply this p with x and factorial with 1. So this x and this one, this x and this one, this x is multiplied with p and this 1 is multiplied with f. So this, let us write it as p by f. So this is p by f. So this one is the result obtained by this function plus p by f. So I will write down the steps once again. This is p is assigned with p into x, this I have to do, and then f is assigned with f into 1, this I have to do. Then the result of this one is 1 plus, this is p by f. So p is x and f is 1, so this is x by 1, so this term is x by 1. So these are the 2 steps every time I will be performing. So I will not write them every time. Directly I will be using this 1 by p power x, and these operations I will perform here. Now let us continue. It goes back with the result. What is the result? The result of this function is 1 plus, what is p by f? P is x and 1. So this will is x by 1. Now in this call also it has to perform this. So this becomes into x, that is x square, and f becomes into 2, this is 2, so into 2, so this is 2 factorial and plus, now in this result it is added. So what is added? P by f. So p is x square and by f is 2. Then the result of this function is returned. The result of this function is returned. So this becomes 1 plus x by 1 plus x square by 2. Now for this function call, again, this p should be multiplied by x and f should be multiplied by 3. So it becomes x cube and this becomes 3 factorial. So plus x cube by 3 factorial. That is 6. Now this is the result of this function call, so this returns and this becomes 1 plus x by 1 plus x square by 2 plus x cube by 3 factorial. Now these steps, as I said, I will not be writing them, but I am performing every time. So into x, so p again into x, this becomes p x power 4 and this is into 4, so this becomes 4 factorial. So that term is added and this is x power 4 by 4 factorial. So result of this function will be 1 plus x by 1, x square by 2 factorial, x cube by 3 factorial, plus x power 4 by 4 factorial. So that's how we are getting the result of a Taylor series for highest power 4. Now let me write a function for this one, which is utilizing variables that are static p and static f and x and n. By using these static variables, we will write a function. So let me write the function here. Return type is integer, function name is e, and taking two parameters x and n. Now here I need two variables. So first of all, I declare some variables that are static int p, that is 1, and f, that is also 1. Then I need one more variable. The result of this function is added by p by f. So I have to take one more variable to store the result of a function. So I will take one more normal variable, r. If n is equal to 0, then when n is 0, it is returning 1. Return 1. Else, what are the steps? First, call itself. So first is call. So e, x is as it is, and n minus 1. The result of this function should be taken in some variable. So for that I have taken a variable r. Let it be in r. Then here in the basic step, I have shown you that p is multiplied by x and f is multiplied with the value of n. So let us do this. P assign p into x and f assign f into n. So these two things will be happening at returning time. So at returning time, the power will be growing. By the time it return back to the first call, p will be having x power 4 and f will be having 4 factorial. So those two are performed in returning time. Now what I have to do? I have to take the result of a function and plus p by f. The result of a function plus p by f. The result of a function plus p by f. Result of a function p by f. This is what I have to go on returning. So return result of a function r plus power by factorial. So this is a recursive function for Taylor series, that is e power x. For the same Taylor series, we'll look at one more approach, which is faster method and takes less number of multiplication for getting the result. So I will show you the approach and also I will write a recursive function for that one. In this video, I will implement a function for Taylor series, that is finding e power x, that we have already seen in the previous video. So just I will write a function and just I will give you a demo of that function. Function name I will call it as e, but return type I will take it as double. While explaining on board, I have used integer most of the places, but actually the result is in decimal point, so I should take either float or double. So I am taking double here and the parameters are x and n. See, x is the power of e and n is how many terms we want. So the more number of terms we take, we get more precision. Then inside the function, we are using static variables, which I will declare them as double. That is p assigned 1 as well as f assigned 1. Then if n is 0, return 1. We need one more variable, r, for storing the result, so I'll declare it as double, and that r assign e x comma n minus 1. And every time p is multiplied by x and f is multiplied by n, that is for denominator and it is a factorial, and return r plus p by f. So that's all, the function is ready. Then from main function I will call it. Directly I will write the result inside printf. Call function 1 comma 10. So e power 1. It should give the result e power 1 and the number of terms that we want are 10. If I want more precision, then this 10 instead of 10 I should give more larger number. Let us run and see what is the output of this function. E power 1 is 2.718282. Let us check it on a calculator. 1 e power x. Yes, 2.718281. So I got the correct result. Let us try with another value. I'll give the value 3 and run it. See, the answer is 20.079665. Let us try it here on the calculator. 3 e power x, 20.08557. And here we got 079. So it is little less than that. So if you want more accurate value, then increase the value from 10 to 15 or 20. So you can give some another number. Let us check for 4. It is 54.44. And here on the calculator, 4 e power x, 54.59. So this is little less than that. If I increase the number of terms, instead of 10, I will give 15. Let us see what result we get. Yes, 54.597, 54.598. So still our value is little less than that. So I can still increase the number of terms to get more precise value. So that's all. This function is finding e power x, that is the result of Taylor series. That's all in this video.